Now what else I can do with these processes is, let's say if something is running like this. When I say ps-af, I can find this process ID. If I don't like this guy running for like this, how can I stop this process from execution? The command here is kill. When I say kill, I have to send a specific signal here, kill -9. It's a sure shot kill, and I just have to say process ID. The process is killed. When I say echo $?, $?, will give me the return status of the previous command, which is non-zero, means something is not right, error. So it says that process ID is killed. The return status is 139. So if I know there is a command in Unix called top command. What does top show me here is, top shows me that how busy is my system. What are the top commands that are consuming resources with respect to the CPU? If I find out a command which is not so relevant for the performance of a system, but it is occupying like 90% or 80% of a CPU, then I'll go ahead and kill that process ID. This is the process ID. That's the job of anyway Unix admin, because they have to monitor it day in and day out your system. Let's say if I complain to my Unix guy that, buddy, look at it, CPUs looks like very slow and system is not responding at all. The first thing, one of the first things they do here is they log in and they see how much is the load. So there are 4 sessions so far, and when I do a top command, so how much is the CPU load? It's just only 1.4%. It's not heavy load, so the problem is not with memory or resources. The problem is somewhere else. How do I exit from here is Q. In summary, what I've been trying to share here is, you have a program, you have a process. Process is nothing but a program in execution, right? In a processes, you have user processes. That means a processes started by user. You have a system processes. They are automatically started when Unix starts. How do I see user processes? ps-ef, right? How do I see all processes is ps-ef? How do I see user processes -af? And there is a command called kill command to kill user processes. Let's look at theory. A program in execution is called a process. Bin ls is a program, but when we run it, it becomes a process. Each process in Unix is given a unique process identification number called process ID. Command ps can be used for viewing information about the current processes. Now here is the syntax options for ps. You can try them at your place. So ps -f, it's a long listing, -af, user processes, -ef, system plus user processes. When I say ps-u and a username, it will show me that process is running by a specific user. If let's say I log in as a root, is showing me here the process is started by a specific user ID. Now whatever we are seeing here is foreground processes. Again, like this guy has here user processes and system processes. The other segregation of processes here is foreground and background. For example, here when I say sleep 200, this is a foreground process. What do I mean by foreground processes? It is running in the foreground and it is actually stopping me from doing anything on this session. How can I put this process in the background? How do I terminate it? Is Control C, it terminates. When I say sleep 20 and if I put an ampersand symbol here, the process will run in the background and it will quickly give me a process ID for it. The process is still running, but the process is running in the background. After 20 seconds, you no longer see this line. Sometimes what do we do is, if we are doing any backup or if you are doing any program which runs for longer time, we don't want to halt our stuff in the system or this terminal. What do we simply do is we put that process in the background, let it run so that I'll continue with my work. You see here it said it's done. 32311. So that's what I'm trying to show you here. One or more processes can be executed in the background without occupying the attention of the user in the foreground. To execute a process as a background process, we have to place ampersand at the end. When a background process starts, its process ID will be notified, and one common area where we use here is when I am trying to copy to huge files, or most importantly when I am trying to take a backup which takes like 30 minutes or like 4 hours or 5 hours. I don't want it to be run on the foreground. So what if I have started something on a foreground and which I forgot to keep it in a background? Can I put it in a background later? Yes, when it is running you can keep that in a background. For example, running sleep 200. I forgot, by mistake I kept it in a foreground, but ideally my first choice is to keep this guy in background. Now you need to press Ctrl Z. You press Ctrl C, it will terminate. If you press Ctrl Z, it will stop its process. Ctrl Z is it stops the process right away. Then you have to say busy. When you say background, the immediate process will be kept it in a background. The process still runs in the background. If you want to see this back again, foreground. If you want to put it back again, Ctrl Z, background. So this is the sequence that you have to play. Sometimes by mistake we start something in a foreground, then we realize that, oh, I did a mistake, I would have started it in background. So these are the sequence of steps you have to follow. Make sense so far? This is the command I have been talking about. Kill is a command to kill a specific process ID. I know there is a background process running, but I don't want it to run anymore. When I say ps-ef grep for kill, sorry, not kill, sleep, there is a 200 running in the background which is started by db2 and st1. Who can kill this process ID? Who can kill my process ID? Is either I or anyone having privileges higher than me. Who is that guy? That guy is only root. So root can kill it. When I say kill -9, root can kill this. See here, it's got killed. One important point here is root can kill any session. Can db2inst1 kill root session? No, because root is a super user, so he or she has a privilege to kill everything on the system. Now what is this -9 is? -9 is a type of a signal that is a sure shot kill. When I say kill -L, it will show me the list of signals available. If you are familiar with electronics, there are various kind of a signals you can send it. This is one type of a signal. 9 is, where is 9? Kill signal. 3 is quit signal. This is a trap signal. I'm not even pretty sure about it, this probably any electronics guy can explain much better than me. But what I use day in and day out is if I want to kill something and if I want to be killed sure shot, I'll go and give this signal line. Right? That means I'm not waiting for this program termination, proper termination. I'm just saying right away kill it. I don't care which state you are, just kill it right away. I'm not sending the terminate signal, I'm sending the kill signal. So what in my opinion, when you send the signal terminate is it will wait for the program a proper close instead of killing it right away. So there is another command called nice. Once in a while what happens is you start something, for example like a backup. The backup runs for like 5 hours or 6 hours. But you wanted that backup to finish in like 2 hours or an hour. What would you do? If it in normal, under the normal workload of a system, if it takes like 5 hours, if you want something to be finished it in 2 hours, you have to increase the resources. For example, you might have studied this in work and time problems, right? If one person can do a work in 10 days, and if you employ 10 resources, you expect to finish the work in 1 day, right? Why? Because you increase the manpower, you increase the resources, so your overall time will reduce. Yeah, that's kind of a logic even you follow here. How do I increase the resources, or how do I increase the input so that my job will complete faster is you need to increase the priority. What did I tell here? On any execution there are 4 important things, 4 important resources. One is CPU, main memory, storage and network. These 4 are crucial for performance. So when I increase these resources, if I give only one CPU cycle, if I give you 100 CPU cycles, there is a huge difference. If I give you only one resource to finish the work, and if I give you 100 resources to finish the work, there is a huge difference you can show, right? If I initially start with one resource, if I want to complete the job faster, I have to increase the resources. Indirectly, we are saying that I have to increase the priority of the job. I have to increase the priority of the job, saying this job is priority to me. There might be 100 different jobs running on the system. I don't care, but this job is the highest priority. How do you set such a priority is using a command called nice. This command can be used for setting the priority when a command is issued. The nice value specified is added to the default priority value. Higher the nice value, lower is the priority. Negative nice value can increase the priority. For example, nice, the number 5, sort file 1. So I'm passing it with the priority 5. I think by default the priority is 20. Right? Everyone will get a 20 priority. If I start reducing the number, that means that job is of an higher priority. If you want to change the priority of already running job, you have to use a command renice. But trust me, how frequently or how important this command is, out of the scale of high, medium, low, I give this importance as low. At least as a developer, we don't have to worry about it. It's the pain of admin in case or it's the pain of an Unix guy, if needed. As a developer or as a user, normal user, you don't get into these stuff day in and day out. But once in a while, you might have to consider this.